well, we have the pictures. What can we do with them and the sensor data, right? And I think the way we should do them is to create a new way of logging, this visual way of logging, right? I think that's the journey into the future. And so it's the idea of combining these sensor data together with the AI to be able to log more effectively. So I actually didn't tell you initially, but if you kind of would ask me what it is that we're trying to do at FastGeo is three things. How do I make you log with less bias? So you see how I'm trying to reduce the bias by showing you the sensor data? How do I make you log faster? How do I get you to log faster with less resources? And maybe that's the next bit of the conversation, which is if I can support you with AI, I should be able to do that quicker. And the third thing is, how do I allow you to communicate the information of your activities more efficiently? So let's look at that second one, which is how do I get you to log faster? Well, if I take that image now and I present it in a logging pane like this, and then let's say these are my suites, we call them suites, you call them form definitions in Acquire, and I'm just going to select my form definition for lithology, for example. And I'm going to click a depth, then begin to see how that depth is depth referenced on the image. See, so 501. And so I can also begin to complement that with the lithology and the rock codes. So I can present the logging visually. So as I'm logging, I'm actually entering the data. But I can do that as well as I can also do the RQD and the recovery. So here's the RQD and here's the recovery because the machine learning engine has processed that picture to give me these segments. Now, our philosophy with machine learning is a little bit different than everybody else. We don't believe the machine learning will be able to replace the geologist. We believe that the machine learning should be able to support the geologist in the tasks that they're doing. So that's why when you see these lines, what we're saying is these lines are the predictions and this is a tape measure. And you can move the tape measure, and when you move the tape measure, the calculation itself changes. So it makes mistakes, right? Like the algorithm makes mistakes, but you have now the ability to change those mistakes by moving these lines. And so we're saying is we're hoping that we'll be able to augment you by supporting you, but it will be ultimately the decision of the geologist to say, this is what I want to log. So we're not allowing anything that is automated. The geologist must make and approve all data that goes into the system. And I think that's a clear distinction between what we're doing and maybe other of our, other people in the industry, right? Like we don't believe that AI will be able to replace what we do, but we do believe that it will be able to support us in making better decisions. So again, removing logging bias, logging quicker, and then communicating the logging more effectively. But if you didn't want to log in this way, and by the way, we can also support this by bringing in the sensor data. So, here's our value of maxus 5 with 0.7. So we can begin to introduce all this sensor data and bring it all together. But you can also do it on a grid-based basis. So this is your traditional Acquire form of logging, right? Where you have your panel and your sheets and your selections. And this can be done both on the screen, but it can also be done on the mobile device. So everything that I'm showing you here is available on iOS, Android, and Windows. So you can log in this way as well. And then those calculations of the recovery and depths and all come in here. And then the third thing that I remember I said was, okay, logging less, reduce the bias, log quicker, and communicate your logging more effectively. So to communicate and to validate your logging, I mean, we're in a spatial science. Like the spatial context is so fundamental to what we do that being able to understand the relationship of this data together in 3D space is fundamental to our activities. But I don't understand why nobody has ever done this together. Like, we put it in isolation. Oh, this is the job of Leapfrog. No, it's actually the job of the logging geologist to be able to understand the context between the holes. It's not to interpret. It's just basically to make a better log and reduce bias, right? So that's why we also believe that 3D representation of the data or sectional representation of the data is very important. it's important to understand the context, and we built those tools. And so what you're seeing here, if I were going to summarize what I've shown you, what I've tried to show you is this. I've tried to say, hey, we have all these tools to capture sensor data, be it the imagery, be it the XRF, be it the Maxos. We have all these tools to put the data and view it together. We have these tools to run machine learning models and create models to support you, and in particular RQD and recovery initially, but you can do more things. We have these tools to log the data, and then we have these tools to connect the data, which was how you opened the conversation as well. How do you connect this to Acquire? And I really didn't show you this, but what I can show you is that we've built the entire architecture. I mean, philosophically, I believe that innovation is driven by interoperability. Like, this is a core belief that I've had in all my career, right? Like, the best way is to connect systems and give the customer ownership of their data in order to drive the product further. So I hate these ecosystems that, they close you out rather than connecting you. And so everything that I've shown you is driven by an API. And what that means is that programmatically, you can do whatever I've done here, you can do programmatically.